Welcome back to Decouple. Today I'm joined by James Krellenstein for a part 3 on Vogtle. I think this is a record on Decouple. We have had some follow-up episodes, but this is really great, and I'm really glad that we're spacing them out. It's not one long recording that we're breaking up. We are recording kind of a week apart, I think, generally speaking. And what's beautiful about that is it's giving a real opportunity for audience feedback, audience questions, and I'm really excited about that format. And I think, both James and I have been getting precisely that kind of feedback, those kind of questions, which are going to make this episode even more interesting. So, James, welcome back.
Thanks for having me, Chris. No, I agree completely. I promise this is the last episode, finally, of this saga. But I
That's not
think
necessarily going
just
to be
before we,
what the audience wants to hear. I have to tell you, but people will be people will be greeting that with
well,
with the opposite reaction.
I
I think.
think I think some may in fact feel this way. But what I really want to though, we were talking right before we started recording. I think we'll sort of finish up what happened at both Vogtle and Summer here. But I think this is a really good excuse me, to think about where we are today in the nuclear energy sector in the United States, and dare I be a little bit American centric or US centric, even in the Western world, because I think what we're seeing here, sort of we're all living in the shadow of Vogtle and Summer, at least in the United States, in so many ways. I think if we think about why utilities are hesitant to order nuclear, even when we've increased social license, increased pro-nuclear support thanks to the work of nuclear advocates, increased the financial sort of stimuli and sort of incentives to build new nuclear, thanks to the Inflation Reduction Act, among many other policy tools that are available through the Biden administration, we're still not seeing it. And, I think I was joking with a friend last week that the tragedy of Vogtle 4 is that there's nothing after it. And that doesn't mean just not another AP 1000. There really isn't a serious new nuclear power project that is happening in the United States right now. We have Kairos, maybe with a test reactor. Obviously, that's not going to generate a lot of power by design. That is got a construction permit from the NRC. We hope to see that start building. Obviously, the regulatory aspect of that is sort of finished from permission to construct, at least. We had the carbon-free power project in Utah, actually in Idaho, but from the Utah Municipal Power, from UAMPS, that got canceled, as I think we sort of foreshadowed in one of our episodes. And we just really are in a place right now where we don't have anything after Vogtle 4 that looks concrete, excuse the pun. And, we see a little bit of, in Cameron, Wyoming, we see TerraPower really try to, looks like they're really moving forward in possibly building that project, but they haven't even filed an application yet with the NRC for a construction permit. So I think we should go back to sort of where we were, where we just sort of left the last episode, where the wheels were really about to come off this project. And I think we should spend a little bit more time on what was going on at Vogtle and Summer, but then really sort of zoom back out and think about what the implications are for all of us. And I think they're pretty profound.
Yeah, that sounds great. And, I think it's interesting seeing the anti-nuclear narratives mature from, the good old-fashioned three-eyed fish, fear, uncertainty, and doubt, towards what I think are, fair critiques of, the performance of the nuclear industry in the last 10 or 20 years. And, it seems like the industry itself and its trade organizations and representatives have not done a great job of actually acknowledging what went wrong, of making that information freely available. So, it's up for this little upstart podcast to jump in and do the work. We're happy to do it. It's interesting, but shameless pitch. If you like this, if you find this interesting, if you think this is valuable, if you think this is good for nuclear, go ahead and get in touch or hop on our Patreon. We could use the support. Shameless pitch over. Take it away.
Yeah. So I think when we were sort of left off, excuse me, we had sort of just started talking about the major challenges that were starting to begin as we began actual nuclear construction at both Vogtle and Summer. And as I think I mentioned before, we could have a 10-part, 20-part podcast probably on every single thing that went wrong here. Remember, this was for a licensing regime that was supposed to be completely done before the first concrete was poured. There were 188, and actually 189 if you include the infamous pipe brace, license amendment requests that were actually needed to be filed with the NRC, revisions in it, to finish this plant at Vogtle. So that obviously we can't go through every single thing that went wrong there. But what we can start talking about is that the commercial pressures of the failures of this project really started accumulating on the project participants, right? So let's just think about what the project participants are right now. At Vogtle, right, you have a consortium of utilities, not just Southern Company, but also companies like the city of Dalton, MEAG, the sort of municipal electrical sort of utility in Georgia, right? As well as, of course, Georgia Power, which is owned by Southern Company, that are building the plant, that are ultimately the owners of the plant, right? They formed a consortium to finance and build the plant and ultimately would take ownership. But the plant is actually being built by, at this point, a consortium of two major institutions. One, of course, is Westinghouse Electrical Company, which at this point is owned by the very large Japanese conglomerate Toshiba. And then there is the EPC, the engineering, procurement, and construction firm, which is responsible for designing and engineering the plant, with Westinghouse, but also doing all the procurement or most of the procurement for the modules, and also organizing the civil labor force of craft laborers and of manual laborers who are actually putting together this plant in Georgia and South Carolina. And then, of course, in the South Carolina site at Summer, we have also the utilities led by SCANA, but also Santee Cooper, building the plant with the same consortium. And the initial arrangement here is a fixed price contract or a near fixed price contract, right? Where essentially there's a fixed price that it's a little bit more complicated than a fixed price that uh, Toshiba and Westinghouse are responsible for delivering the project to the utilities. And this becomes a major challenge. Even before we started nuclear construction, we started actually seeing lawsuits, litigation between the two companies, between the consortium and between Georgia Power and the owners over who is going to basically pay for some issues that they had even before they got the license of doing the structural backfill that was necessary to bring up the plant. They actually literally sued each other starting in 2011, 2012, right? Which is sort of, unfortunately, I think, a harbinger of what's about to come throughout this sort of construction. So the first big event that happens commercially is that Shaw, which was the company, the EPC that was building the plant, and had bought an old esteemed nuclear EPC called Stone and Webster, which built dozens of nuclear power plants in the United States. They get bought by another company called Chicago Bridge and Iron, CB&I. I think we talked about this a little bit. And CB&I starts, assumes responsibility, but begins looking at this project and sees, hey, there's a massive liability here that we have on completing this project on time and on budget contractually that we owe as a contract to the project owners. And we don't want to assume this responsibility. So CB&I, in addition to what were at this point numerous pieces of lawsuits between even Westinghouse and CB&I over, for example, who should be held responsible if CB&I, if their facility in manufacturing a module is late because Westinghouse didn't actually get a finalized design over to CB&I, who should be responsible for that delay, right? There's commercial implications for this. And rather than, I think, settling this in an integrated project, sort of one team, one mission fashion, they start suing each other. So things are beginning to bring down acrimoniously even before we get to this point. And CB&I basically is saying, I want out, right? I want to quit. I want to figure out a way to get out of these two builds because they look like disasters here. So we already are seeing that there is major commercial tension, and CB&I figures out a way to literally sell, essentially, the Stone and Webster unit, their sort of nuclear EPC unit that is responsible for building and procuring and constructing this plant, actually to Westinghouse. And there's an idea here that Westinghouse is going to assume 100% of the build's responsibility. They're going to build what's something that a nuclear vendor in the United States has never done in U.S. history, at least in the modern commercial build out, where it's going to not only provide the nuclear steam supply system and the nuclear island engineering, they're going to do the entire balance of plant engineering, the entire construction management. This has never, ever happened. No nuclear power plant in the US has been built in this fashion. Sometimes the utility will do the EPC work, the architect and engineering work, and the construction work, but never is the nuclear vendor, responsible for the entire full stack of the build.
Well, and particularly a
But
vendor that already seems to be overwhelmed and like from the get-go is delayed on delivering the design. This seems like a crazy thing to
precisely,
take on.
this seems like a really interesting idea, and I think the major issue that Westinghouse feels itself is that CB&I wants out. No one wants to buy this, and Westinghouse wants to complete the project. So they're kind of in this bind of, well, how do we do this? And so Westinghouse buys the Stone and Webster unit of what was the old Shaw Chicago Bridge and Iron, and assumes basically 100% of the responsibility of building a nuclear power plant. And once again, this is weird, right? In a lot of other countries, right, maybe with arguably more successful nuclear power builds, fleet build out, right, we generally actually do see like KHNP, right, has something called Team Korea, right? This idea that there's going to be a unified sort of, or dozens of organizations coming together to build a Korean nuclear power plant. In France, right, we generally have Framatome and EDF, which both have the same majority owner, the French state, building their nuclear power plants. In Russia, we have Rosatom, right, which both is providing the reactor, often providing a lot of the components, and actually building, doing the engineering, procurement, and construction work. For a variety of reasons in the United States, that never has been the way that we've done it. We've always had this system of, you had 4 big reactor vendors, and you had a whole bunch of different architects and engineers, and then even sometimes different construction firms trying to build the plant. And this is what actually explains so much of the heterogeneity in the Western nuclear power build, in the U.S. nuclear power fleet build out. Why just even the same reactor designs have very different balance of plants and support systems.
I don't want I
So
don't
okay, so we
I don't wanna, like,
yeah.
distract you too much, but I do just wanna note because you mentioned, this plant was on a fixed price contract, and the most recent, AP1000 announcements internationally at least, I believe in Czechia and Bulgaria. The Czechia one fell through because the Czech government, I think, demanded a fixed price contract, and similarly, the Bulgarians, there was this announcement that it was almost like a done deal or an MOU had been signed. I know MOUs don't really mean much, but the Bulgarians are saying, "We want 2 AP1000s for 14 billion fixed price contract," and that seems like lessons were learned here, and at least in the West, that's unlikely to happen again. I think Oikoloto as well. The Finns didn't really lose out because I think EDF or Framatome or whoever was constructing had agreed to a fixed price contract. So, just a footnote. That's those days seem like they're over in the West.
And the Koreans, not only is it the French, Westinghouse, right? So, as you said, the Finns sort of made out like bandits with Okuluto 3, because the French state had to literally step in, and thank you, French taxpayers, to basically finish OL3, right, for a fixed price to TVO, the Finnish utility, but it was way, way over that budget. The same thing happened, of course, at Baraka, which is often held as the successful nuclear build in the Western world, right? These Korean-led consortium that built these 4 APR 1400 plus units in the United Arab Emirates, right? That's a similar situation where actually, from what we understand, KHNP lost a lot of money on that project because the fixed price that they basically had agreed to, and once again, this is a little bit more complicated than just saying it's a fixed price contract. The actual way these contracts and scopes are defined is a little bit, doesn't necessarily, can be described in a single term, but it was more fixed price ish than what we normally have in a lot of other nuclear construction, which we call cost plus, which basically means that the EPC bills the customer ultimately for their cost of doing a task plus some agreed upon profit that they're going to actually make on the task. And there, we should note that although a lot of people love the idea of fixed price, there's a lot of arguments in the history of nuclear construction that actually other contractual arrangements have worked better, actually, for all of the different project participants. Because one of the things that you find, and I think we actually, to get back to the AP 1000 builds in South Carolina and in Georgia, was that in a cost plus arrangement, if you look at like the business school, in a fixed price contractual arrangement, if you look at the business school studies on this, one of the things they say is that the EPC, for example, is not particularly incentivized to be 100% transparent with the ultimate customer, because what they see as additional work that maybe needs to be done to fix something, that's going to be additional cost drivers that they don't want to necessarily either fess up to, or sort of you can imagine within the EPC structure, individual people within the management team are less incentivized to proactively find tasks that need to be solved. And this is why some of the most successful nuclear power builds in terms of price and time in the United States have not been have not been fixed price, but either have been cost plus. And I think we start actually seeing a lot of this in the Westinghouse build, in particular, right, in the AP 1000 builds. One of the things we touched on before was that the customer was just completely unaware of how immature the design was. And it's not clear, even at this point, how aware Westinghouse was in the early points of the builds about actually what percentage of the AP 1000 build was certified for construction, was issued for construction in terms of those work packages. As I think we've talked about, the numbers went down over years of the percentage of the design that's actually done, which is obviously the opposite direction that you want to see, and sort of says something is wrong. But I think that may also point to a major lack of process control within Westinghouse. And, a listener sort of asked over email a couple of days ago, why did Westinghouse not complete the design? Why did Westinghouse not only not complete the design for the US builds that is starting to make this massive, and what we'll see is it gets much, much larger, of a sort of corporate collapse nightmare? Why did they do this? And I don't think I know the answer to this. And it would be great maybe if Westinghouse, sort of fessed up and sort of explained to the public, especially considering that they're trying to get other people to order AP 1000s, what happened at their corporate management level that allowed this to happen, and why it won't happen again, hopefully. But I think, we should be clear that Westinghouse had not been responsible in this way for building a new nuclear power plant in a very, very long time. From a construction, from a sort of, greenfield or brownfield site, building it up. They were helping finish nuclear power plants like Watts Bar that had been in construction for literally 40 years, right? They had, obviously been, working as engineers of record, assisting other nuclear builds of different NSSS vendors. But this was the first time, I think, since maybe Sizewell B, I'm not so sure when the last Westinghouse plant was, that they really were responsible as an actual nuclear island vendor from the beginning to the end of a new nuclear project. And I think there was just a lack of, maturity in sort of this company at this point. They were rusty, and maybe that's to be expected. I don't think it's an excuse, but it's at least somewhat of a cogent example. And I remember talking to someone within the AP 1000 design team who worked at Westinghouse and just said, to get a design change in the late 2000s at the AP 1000 design, was a manual process at that point, still paper-based process. And it required weeks of people sort of getting together and having all the different teams interface together. And you actually literally had a physical meeting to do it. And just that sort of process, that sort of basic processes that we expect in design change and revision and design control, just weren't at Westinghouse as they should have been. And I think this is indicative of a rusty nuclear industry trying to come back to life. But it had such profound costs. So let's go back to where we are. So basically, CB&I quits and sells the Stone and Webster sort of division over to Westinghouse. And Westinghouse then all of a sudden attempts to manage the entire project themselves, right? Takes over the entire consortium. And this only lasts a couple of months. And literally, Westinghouse begins saying, you know, we actually need someone else. So they go over to a different EPC. Oh, sorry, go ahead.
No, I'm just curious because so Westinghouse is owned by Toshiba. Toshiba is this, massive Japanese company. Did they do like ABWRs in Japan? Do they have other nuclear expertise? And if so, did they bring any of those Japanese resources and that more recent experience over to help out at Vogtle? I'm just curious. Like you think of Westinghouse as this American company all on its own here, but they are owned by a much bigger consortium that
Yeah.
presumably has more recent experience.
And not only does Toshiba have experience in building the ABWR, they actually even have an ABWR product line that they're independently marketing. That's actually marketed successfully, partially at South Texas Project Unit 3 and Unit 4, new plants that never were built. They also have their own pressurized water reactor line, I believe, as well at Japan. Not a particularly good one, I don't think, but still, they have a lot of experience. It's not exactly clear why that Toshiba experience isn't being translated down. What you do start seeing, just to be honest, in sort of the documentation is that these supply chain issues that have really, on the modules that have plagued this project, we do start seeing a bunch of the work transferred over mid-build to Japan.
To
To
Japan.
companies like, yeah, not
Wow.
only Toshiba works, but IHI begins fabricating a lot of the submodules, right? IHI is sort of, relatively prestigious Japanese heavy manufacturing combine. And so we do start seeing a little bit of Japanese sort of, you know, input, but we don't necessarily see maybe at this point the project control, the management, the sort of the management and build and engineering philosophy that I think was so instrumental in the advanced boiling water reactor builds with General Electric, Hitachi, Toshiba, and then in the first case TEPCO for KK6 and KK7. That sort of integrated sort of project, very Japanese, almost like, seems almost, forgive my if this seems a little naive, like almost like Toyota production management sort of approach with Kaizen and sort of continuous improvement and planning every single thing out. That does not obviously be translated over, I think, much to, everyone's fault. But Toshiba ultimately is responsible for backstopping Westinghouse. And what begins happening is that Toshiba is having to report as a publicly traded company in Japan that they have this massive liability to these two different utilities. And literally, the liabilities are so large that Toshiba, a illustrious, large household name that makes microwaves and turbines and massage, televisions, right, computers, right, they are literally threatened. Toshiba's stock begins plummeting as they begin reporting the liability exposure that they have out of their Westinghouse division because of what's going on in the Vogtle and Summer plants. So even the very, very large, and there's even talk of the need maybe of the Japanese state to come in and step in and backstop the Toshiba because its financial solvency is being so threatened by the liabilities that are implicit in these project builds. So what happens? Well, so two things begin happening. First of all, this idea that Westinghouse is going to sort of manage the entire thing, I think everyone realizes pretty rapidly that's not a great idea. And they bring in another EPC company out of Texas called Fluor, which has some experience historically in nuclear power build. Obviously, it's a very, very large, well-regarded engineering, procurement, and
And the new
construction firm.
scale backers.
Exactly, and would later become the NuScale backers, backing a NuScale. Fluor gets involved in helping manage this project, and basically, Fluor also doesn't particularly work out. So you have basically the utility. So at this point, SCANA, right, this sort of the South Carolina project, is so far behind, and they begin realizing that the testimony that has been provided both by Westinghouse and by SCANA executives to the Public Service Commission of South Carolina, which is responsible for protecting the ratepayers of South Carolina, a lot of that likely was actually, and we now know this because there's been criminal prosecutions, and people have pled guilty or actually been found guilty. A lot of the sort of updates on the status of the VC Summer Units 2 and Unit 3 builds are likely actually, people were plagiarized and they weren't being honest, even though they were under oath, with the Public Service Commission. And this leads a decision to cancel those projects completely. So $9 billion in the hole, the ratepayers of South Carolina are left with a rusting, heap of two half-built or quarter-built AP1000s in South Carolina.
And
Go
just
ahead.
just very
Sorry.
briefly, I don't want to interrupt the flow too much, but are those units a write-off now? Like I've been talking to Mark Kwango over in Philippines, and we talk about the Bataan plant, which is a laid up. Not sure if it's a BW or PWR. Anyway, it's a smaller new
PWR.
PWR. And yeah, I mean,
Two-loop Westinghouse, actually.
yeah, and they've mothballed it carefully, and I think the NSSS is okay, but the balance of plant is kind of rusty and would take a major overhaul. Like, could that South Carolina VC Summer come out of the ashes and rise again, or is it all rusted to shit?
So, the Philippine Bataan nuclear plant, which is a Westinghouse two-loop, old style Westinghouse two-loop plant, like a Ganay or something. That plant was really completed, and just never was turned on. And the whole NSSS was not only assembled, not only as a containment dome on, right? Like they actually did all the radiographic and non-destructive examination of the NSSS and really was ready to go. This is not what Summer is like. Summer, if you look at just the aerial photos, right, there's no roof on the containment, right? You can actually still see in the aerial photos, you can see the steam generators that are actually there, right? Just from the satellite photos, because there's no roof on the containment. And so I've not been to that site. I don't know, but I would imagine requalifying those components as part of your 10 part 50 subpart B and then NQA1, right? I don't, I haven't thought about that problem particularly significant. I would imagine that would be a very, very non-trivial task. And speaking to some nuclear engineers about this, they would say, in some ways it might be better to start from, either tear everything down, start from the base mat, or maybe even just start fresh, because there's a possibility of all rusting. Now, I don't know I don't really, I haven't looked at this in any depth, but there isn't a roof. The turbine building is not done, right? You can see the sort of structural frameworks of the turbine building. You can see directly into the containment because there's no roof on the containment.
But
I don't think even the shield. Yeah.
Yeah, that gives you a sense of how far along it was. Like when I don't know much about a lot of things in nuclear, and I just thought Summer maybe got to the stage of like the base mat and the civil works and the concrete's poured and nothing else was done. But they dropped in some monster modules, as you're saying. Like this thing advanced quite a ways.
And not only that, a lot of the major components of the NSSS are on site. The reactor pressure vessels there, the steam generators are there, the pressurizer is there. Reactor coolant pumps are actually
This would
there.
be a great
In fact,
theme park, a great theme park for nuke bros, because especially like I've visited a lot of nuke plants, but it's just the turbine hall, turbine hall, turbine hall. I'm like, I want to go inside containment. So I mean, at least I could be a very minor source of income. It wouldn't pay back $9 billion of sunk cost, but I'd pay a couple $100 to go tour it and have an nuclear amusement park there.
The unfortunate history of the United States nuclear industry is that Summer 2 and 3 is hardly the only abandoned nuclear project mid-build, right? There are dozens and dozens and dozens of nuclear power plants of various build states, all abandoned throughout the United States. I mean, what's good, I grew up, of course, in Long Island, and we have a beautiful nuclear power plant out in Suffolk County called Shoreham that literally was complete, not only complete, did low power testing and never turned on. And that's a full blown thing. You can actually sneak in there, allegedly you can actually sneak in there. And there's videos on YouTube you can find of people rummaging through the plant, including in containment, right, of the entire thing. It's like an hour and a half, and it's actually quite scary and probably pretty dangerous to do. I don't recommend that. Don't do that at home. That's not the only thing. I mean, think about Marble Hill in Utah, in Indiana, right? Think about the abandoned Washington Nuclear Project 3 and 5, Washington Nuclear Project 1 and 4, right? They're all there, right? And they're all
is this a US phenomenon? Because you got to be a rich, wealthy country. I mean, I guess you said Philippines also abandoned, so it's not just US, but the sheer quantity of half-built sites is that.
Yeah,
you see that around the world?
I think no, you don't, and I think this has to do with the fact that we don't have with the exception of the Tennessee Valley Authority, right? We don't have a federally backed utility. Now, TVA, of course, has also two very large, almost complete abandoned nuclear projects in Alabama called Bellefonte, which were Babcock's and Wilcox pressurized water reactors, right? That if you look at them, they look like a complete nuclear power plant. And you can go, there's actually a lot of people who've been trying to buy that site and turn it back on. So that's not, it is a weird quirk of the United States that we have these, half built, three-quarters built, in the case of Bellefonte, 90% built nuclear power plants. And, some of them, Watts Bar 1 and 2 are the example that I would give, have been actually, construction has been resumed and the plant's actually finished, right? Watts
But
Bar 1
that's
and 2,
TVA.
Watts Bar 1.
That's TVA. That's
That's
federal government
TVA.
backed.
Watts Bar 1 came online in 96, and then Watts Bar 2 came online in 2016, 2015, something like that. And so, and if you look actually at the data, like those plants started construction in 1972 and completed in 2016. So they're like one of the longest nuclear builds in U.S. history. But we could go on about this. Most nuclear, if you go to a single unit nuclear plant, just one more point here, if you go to like a nuclear power plant like Seabrook, right? If you look at Seabrook, you'll notice that there's unit number 1, which is fully finished generating power. And then next to it, there's another turbine building and this like weird half-built concrete structure, which is Seabrook Unit 2, which was abandoned mid-construction, right? There's so many of these actually. One last point, and then we'll move on. The film of The Abyss by James Cameron, right? This was a film that was filmed in the abandoned containment building of Cherokee Nuclear Power Plant, also in South Carolina, that was never ever finished, right? So the U.S. is just filled with the rusting hulks and the careers of the utility executives who ordered them nuclear power plants, which is a really important thing to understand. And I think it's horrible. I'm just going to be frank. And, once again, the Kraft macaroni dinner may need to come out here. But it is horrible that we ended up this way in the nuclear renaissance of the noughties, to use your terrible term, if I may be so bold, right? Like that, the fact that we ended up again with an abandoned hulk of 2 nuclear power plants, billions of dollars that the ratepayers are responsible ultimately to pay. That's how we got. And it's the same story, unfortunately, that led to so many of these abandonments previously, right? And that same story is these projects went way over budget, way over schedule, and just seemed like a managerial and commercial fiasco. And therefore, the utilities thought it would be more prudent to the Public Service Commission to just abandon them, cut their losses, rather than complete the plant. And I just can't emphasize again how I think destructive this has been to new nuclear build-outs in the United States. And, to go back, so we now have Toshiba Westinghouse goes into bankruptcy mid-construction of this plant. And you literally have Southern Company, which kind of heroically and the Georgia Public Service Commission, which is agreeing to allow the continuation of this nuclear power plant build, which is an amazing sort of story. And I think we should be, one, respectful for both Southern's perseverance here, their decision to actually start taking the management of the plant, the construction of the plant themselves on, and also the Georgia PSC and the Georgia ratepayers who are saying, we're going to finish this. It's going to be better that we sort of finish what we started rather than we just have billions of dollars of debt with nothing for it. And we have, the Loans Program Office under both President Obama and under Trump begin actually expanding the amount of loans that can get guaranteed to finish this project. So we have a lot of government support sticking in, starting to come in. And so here we are at this point where they take in Fluor, right? Westinghouse doesn't want to manage it. Westinghouse goes into bankruptcy, okay? And it's so serious that actually Southern Company demands that when they go into bankruptcy, that all the intellectual property assets that Westinghouse has associated with the AP1000 and the software codes, the regulatory codes, everything goes into an escrow account. Virtual escrow account held by their lawyers, so that if Westinghouse no longer was able to sort of continue as a continuing entity, Southern would have the ability to use those IP to finish the plant alongside.
Holy mackerel.
So Southern takes over. They realize Fluor is really not competent as a That's unfair to Fluor. For whatever reasons, and I don't have any insight into them, they decide that it would be better to go to Bechtel as the EPC. So just let's go through here for 1 second. We have now gone through in this single nuclear power plant project at Vogtle 4 arguably different EPCs, right? So we started with Shaw, and Shaw owned 20% of Westinghouse at the beginning of this. Then Shaw gets owned by Chicago Bridge and Iron. Chicago Bridge and Iron says, this ain't for me, right? Sells it back to Westinghouse. So now we have Westinghouse managing the old Stone and Webster sort of EPC. Then we go over to Fluor, and then we end up at Bechtel. So I guess actually I counted wrong. That's 5 really there, right? In a single project at a single site for building 2 true reactors. That is pretty horrific. And I got to give amazing credit to both Southern and Bechtel, because Southern and Bechtel really do turn around this project and begin actually building a really competent quality assurance team, a really good licensing team, really actually start building up the sort of project control and project management that was lacking in this project from the get-go, and working with Westinghouse in bankruptcy to really finish this project up. And part of the reason is that Bechtel, I think, even people from other EPCs will admit that this is the most, has historically and today been the most nuclear experienced EPC. Not only is they're the single largest EPC that has built the existing U.S. nuclear power fleet, they also have a pretty large sort of naval reactor program. And as you know, for example, the nuclear reactors, the core design on the Gerald Ford class of aircraft carriers was actually designed. The core is the A1B core, right? Because it's a Bechtel core. So they really are very, very sophisticated and arguably had that experience, both historically and in the present, to turn this project around. And they did. And that project, we end up actually finishing this project with Westinghouse in bankruptcy. Toshiba sells it over to Brookfield's distressed debt, sort of the Brookfield distressed debt private equity arm of Brookfield, buys Westinghouse out of bankruptcy. They renegotiate a contract between Bechtel, Westinghouse, and Southern. And we finish the project roughly about 10 years of nuclear construction. About $15 billion over the initial sort of estimate of what the cost was. So double the actual cost of the plant, with 2 casualties in South Carolina. And we see the CEO, COO of SCANA go to jail. We see a Westinghouse engineer who was a very senior engineer who actually worked on the Chinese plants as well, also plead guilty just recently to fraud in South Carolina and is facing a possible jail term for what happened in South Carolina. We see the ratepayers of South Carolina having to spend $9 billion for this rusting hope that's not going to ever, well, maybe, at least right now, not going to generate a watt of power. And we have Vogtle 3 and 4. Vogtle 4 is critical now. Vogtle 3 is commercially operating and doing great. Kind of thank God we actually had that perseverance of both the PSC, Bechtel, and the Westinghouse staff and Southern really actually come together and say, we're going to finish what we started, which I think was the right decision in hindsight. And we have the Chinese nuclear power plant builds, Sanmen and Haiyang, which were also the AP1000 builds. They also finished, but they were also, Sanmen Unit Number 1 was the longest nuclear power plant build in Chinese history. Right, China is a country that is fantastic at building nuclear power plants. The median time to build a light water reactor for nuclear construction is about 5.5 years. We are more than at 9.4 years to finish Sanmen Unit Number 1. We are more than 2 standard deviations outside of that build time, right? And
not that far off from Vogtle build times.
Not that far off in terms of nuclear construction, right? Vogtle was about 10 years. And remember, Vogtle had not only this challenge, Vogtle was finishing construction during COVID. And a major issue that suddenly all happens, how do you build a nuclear power plant, which does not actually turn out to work very well from remote work, right? Construction turns out it's not a great remote work. You can't zoom into this. they had that major challenge of building it. They had the aircraft impact assessment rule, right? Unlike the Chinese build. And the actual nuclear construction time is not that significantly different. It's about 6 months to 8 months longer. And so it really does show that, I know that there's a huge sort of industry almost that nuclear advocates have created of figuring out ways to blame the NRC for this sort of debacle. I don't think that the NRC, of course, is challenging. As I said in the last podcast, complying with the aircraft impact assessment rule was challenging. No one's going to say it wasn't. But to argue that this was the issue, when we have this example of Sanmen and Haiyang, where they're basically about the same time, and we know that in China, we have built 42 reactors in the post-Fukushima era, or brought them to operation in the post-Fukushima era, large light water reactors of various different kinds, of sometimes first of a kind, where we have an experienced workforce, experienced managers, a great regulator, right? We didn't have to comply with the aircraft impact assessment rule. And even then, the AP1000 builds there were about as long as they were in the United States. It really does point that maybe there's a common factor here, which is the mismanagement of the project. And what's so interesting to me is that I think that considering we finished 3 and 4, Vogtle 3 and 4, when I first entered into the nuclear advocacy realm, quote unquote, rather than looking at this from a more engineering perspective, the thing that I kept on saying, well, our number one task, of course, is to understand exactly every single thing that happened at this project so we can make sure not only that it doesn't happen again and make sure that the companies involved and utilities, we can advise them how to prevent this, but in some ways, even more importantly, explain to a rightfully skeptical public why this won't happen again. And what I was so shocked by is that we got instead, so much of the nuclear advocacy has been focused on, frankly, fake stories about how the Nuclear Regulatory Commission was the major issue. And I'll give you one perfect example that was in my first maybe month of being involved with the advocates. There was this story, I believe I traced it back to a blog post or a Substack post that Jack Devaney made, that there's a $30 million pipe brace at Vogtle 3. And the reason why it cost $30 million was because the Nuclear Regulatory Commission required a license amendment, and it would take 30 days for the NRC to issue this license amendment that was required for the simple pipe brace. Without the NRC, it would have been done in one day. And as I looked into this issue, and the NRC is the most transparent federal agency in the United States, and literally their entire document management system is public. Right, as the documents come in, you just can see it online. So I'm literally looking at not what the NRC is saying, what Southern is saying about this. I'm like, this is absolutely incorrect. Like, it just was made up from thin air, right? It is true that there was a license amendment that was required in order to fix the problem in a more expedient era, but the NRC issued that license amendment in less than 2 business days. I think in 34 hours from when the request was actually made. And it was so fast that it was faster than it required the actual the material and the labor force that was needed to repair the plant was on site. The NRC license was there. Right. And I'm just sort of like, why are we pretending? Why was there such an incentive to blame the Nuclear Regulatory Commission here, even to the point where we're making up this story? I can tell you what happened at the pipe brace story because it's a really good story. And there was op-eds written about this by nuclear advocates. Right. There were huge Twitter threads, and none of it had any grounding in truth.
So what happened?
So what happened was, okay, so like when Vogtle 3 had finished, basically went through a process called hot functional testing. What does that mean? That means that we have the plant's basically done. We want to basically fill the reactor coolant system up with water. We're going to run the reactor coolant pumps up, right? There's no fuel in the core, right? But we're going to heat up the system and bring it up to pressure, bring it up to temperature, and run the RCS without any fuel in the core. How do we bring it up into temperature? Well, the reactor coolant pumps on these things are so massive. Remember, when the AP1000 is at full power, it is moving 15 tons of water per second through the core, right? So you can literally just bring up the reactor coolant system up to temperature and pressure by simply just running the reactor coolant pumps, even with no fuel or no decay heat load in the core. So we do this for the first time, and we're doing this to check for leaks, to make sure that actually, everything is fitting together. But it's the first time that the RCS is at temperature. And if you think about what the reactor coolant system is, it's a lot of piping, a lot of vessels, a lot of valves, a lot of pumps. They're all steel, and they're going from room temperature basically up to a couple hundred degrees Celsius, right, to over 300 degrees Celsius. So literally, the plant expands. The RCS literally physically expands, and then when you cool it back down, it contracts, right? So it literally can. The structural dynamics of an RCS can change based on that first heat up and cool down. But when we heated it up, we did hot functional testing. It was all fine. There were some issues, but we fixed them. Cool. So then we go to the NRC, and the NRC gives permission to load fuel into the core. So we go up to the core, and we have the reactor shut down. Remember, the fuel is unirradiated, so there's no heat being emitted. The fuel's almost it's a little bit radioactive, but you could hold it in your hand and it wouldn't be a problem. So we do another thing called pre-critical testing, where we, again, with the fuel in the core, we start bringing the reactor coolant system up to temperature and up to pressure and testing it out. And what happens is we begin seeing, and this is in December of 2022, what happens is we get alarms in the control room, which is saying that that there is a high vibration levels on the automatic depressurization system on stage 3 and stage 4, which is, if I remember correctly, the ADS is at this point for stage 3 and stage 4. The assembly is actually on the top of the pressurizer, and we're realizing that there's a vibration that's so significant that was not seen in the pre-critical test, in the hot functional testing, that it's alarming in the control room. Obviously, this is not good. And the first clue to the nuke bros should have been, you do not see unanticipated vibrations in the reactor coolant system that is so severe that you're alarming in the control room, especially of a design that has been built a couple times before. And they can't figure this out. Why did this not happen beforehand? What is exactly causing it? You shouldn't see this. We've obviously brought this plant up to temperature and pressure before. We've had the Chinese plants that are operating. They have the same sort of design. What's going on here? And it takes them literally almost a month to figure out what the issue is. And when they do a walk down in early January of 2023, they realize that a huge number of the pipe supports, the sort of piping support modules that were supposed to be installed they're not actually modules, let's call them, they're components of this, hadn't been installed, just simply had not been installed by the workforce, and had not obviously been caught by the QA/QC sort of processes that we have at a nuclear power plant at the construction. So what is the fix? Well, the fix is to install the components that were actually in the original plant drawings. The problem is that under the technical specifications that Southern itself had written, right, you couldn't disable the automatic depressurization system when there was fuel in the core. And rather than them having to defuel the core, which would have taken much, much longer, they said, hey, NRC, we need to amend our license because there's no actual safety problem. Even if we lose coolant, right, the fuel has never been irradiated. There's no decay heat load. It's okay, right? You can hold, there's no source term, there's nothing. So we should just amend the tech specs so that it just says the ADS has to be operational once the core has gone critical, right? So that the core hasn't gone critical, it doesn't need to be functional. So they went to the NRC. They submit via email a draft emergency request. The NRC convenes an emergency public hearing the night that the request comes in, and the next day issues the license amendment request. And literally, so this is literally less than 24 hours. The actual repair time is over 10 days. Turns out actually took a little bit longer. So what I'm trying to say here is, here the NRC wasn't in any way a barrier to the resolution of what was admittedly a significant problem, but it's not the NRC's fault, right? This should have been caught by the QA/QC. This should have been installed in the first place. The quality assurance, quality control sort of processes at the build should have caught this. It's okay, right? These sorts of errors happen. This is why we do 2 rounds of testing, among many other things, before we bring the core critical. What I find so interesting about this is, here we have a project that is $15 billion over budget. And we have a huge amount of press that is generated over this that is based on a story that has no relationship to reality and is basically predicated on the idea that a $30 million pipe, cost overrun was the NRC's fault and a $15 billion cost overrun when the NRC wasn't at fault at all. And my basic question to us is, why are we focusing on that issue? Why are we focusing on a made up issue? And we can go through recent nuclear advocacy, and it always amazes me how much stuff is made up here about blaming the NRC. But I don't think the NRC was the primary barrier to the completion of this project. And my argument is a simple one. Go over to China, where the NRC has no authority, and they took basically as long to finish nuclear construction as they did in the United States. No aircraft impact assessment rule, no NRC. We have our little case control study. Explain to me the issue here. And I'll go one step further before I let you patiently speak. One of the things the NRC just did, as Vogtle 4 ITAC'd out, is they released a 35 publicly page, I think it's actually a little longer than that, public report on the lessons learned. How can the NRC do better in the Part 52 process, right? As we bring more power plants. This is the first time we brought a nuclear power plant under this one-step licensing process. What are the lessons learned? And there's criticisms of what the NRC did, what needs to change at the NRC. And I think that's a really healthy thing, because of course the NRC was not perfect in this. The NRC, in many cases, probably should have helped the vendor a little bit more, should have been less particular. But they're fessing up to that. They're releasing this for public comment. My question to the nuclear energy industry is, where's your report? Where is the report of the industry saying, hey, obviously a lot of things went wrong here. What can we do better? And the thing is that when you're building a large light water reactor, this is a social contract that we have, because ultimately the ratepayers, you and I, are paying for that at the end of our bills. And I don't mean to sound like an anti-nuke. I'm not an anti-nuke. What I'm trying to say is you can't have people go to jail. You can't have a $9 billion project failure and then just say, oh, everything is okay. Just trust us. The next one will be good. We need an honest appraisal of what went wrong and what the steps the industry is taking to fix it.
No, I mean, all I was going to ask, James, was, if you could provide, and I think you just did, like that balance of like, okay, this is not obviously it's been scapegoated as the main driver for a variety of reasons, which I think are difficult to comprehend in the way that you've laid it out. But what is an example of the NRC going a little overboard or being obstructionist, either in this project or otherwise? Just one. I don't want to take a lot of time on this, but just to provide that balance of like, what's an example of the NRC screwing up and obstructing?
So you can argue, we've talked about this before, that the decision to require the aircraft impact assessment rule, I think ultimately for a large light water reactor, it's actually kind of doable, but it's going to drive costs, it's going to drive complexity of the project. I think that's something that we really need to have a much more concrete discussion amongst ourselves and amongst the public about whether this makes sense. Obviously it was put into place with the NRC basically being threatened by Congress that if you don't do it, we'll pass a federal law that will require the NRC to do this. And it is a rulemaking that the NRC has right now to basically, they could actually change it themselves. The commission could just change the regulations if they decided to. We really do need to think about whether that's a good idea. Now, I think a lot of people are going to argue that there's these huge issues in the first 6 roughly of the license amendment request had to do with the rebar design of Vogtle 3 and Vogtle 4, and there's actually corresponding ones at Southern. And it turns out that there was extremely high tolerances that the NRC was holding the licensee to that rebar design and the rebar specs, as well as also the mud mat configuration, right, which the whole base mat was going to be built on. Now, we can argue that the NRC was way too pedantic about that and should have not been holding to the tolerances that they actually ended up holding the licensee to. And this delayed the project a good amount. But my problem with that argument is that the tolerances for those, both the rebar designs and the mud mat build, were not, imposed by the NRC. They were actually the license that the applicant itself submitted to the NRC. And the NRC said, well, okay, this makes sense. If you want to build to those tolerances, we'll approve those tolerances. And they had to go through a license amendment process mid-build to revise those tolerances, right? But the question is the NRC is sort of like, they're sort of like your, you try to build a house, and you go to a zoning board and you say, this is the design I want to build. The zoning board's job in many cases is not to say, well, actually it's going to be easier to build that house if you build it this way rather than that way. And I wonder, maybe the NRC could have been faster in improving those license amendment requests. I think that's a fair argument. I think they were pretty green too. But I'm not so sure that you can say it's really fair to say that the problem is the nuclear regulator didn't tell you that you were being, tuning the wrong design tolerances in your own license application. And why I'm saying this is not because I'm a huge NRC stan. I think that the environmental impact statement issuance process is a disaster at the NRC, although much of that is required statutorily by the National Environmental Policy Act. We saw that come into not only an issue at Vogtle 3 and 4, but the issuances of the Turkey Point 6 and 7 licenses, which took years to do. The problem there is that, one, that's required by NEPA, but two, I want to go back. If you compare this nuclear power plant build in terms of the NRC involvement compared to any historical nuclear power plant built in the United States, it is hard to see how this is not a step change in the way the NRC was behaving compared to what it was comparing in the 1980s, right? Where we had huge regulatory instability as the post 3 Mile Island sort of regulatory changes started happening. And under the two-step licensing process, plants in construction had to comply with regulations that literally did not exist when that plant was built. And if you compare that process to where we are with Part 52 and with this design certification, subpart C process, it's a totally different world. On the other hand, one of the lessons that we did learn, and you see GE Hitachi taking this lesson to heart, is that it maybe doesn't make sense to build your first of a kind plant using this one-step process, because this one-step process is assuming everything is finalized before you begin construction. And that obviously was a major delay.
Okay, one question, and I know it's I can never keep you to a quick answer, and that's okay, because I
I'll
love these
try to be
answers.
brief, but it's a hard.
Just briefly, in terms of the aircraft impact assessment rule, or whatever the rule's called, like why do some people feel it's essential and some people feel it's unreasonable? I think it's harder to fly an airplane into a containment dome like close to the ground surface than a massive tower in the New York skyline. But that's the only rationale I've heard as to why it might not be necessary. Can you just briefly?
I think the argument is, the basic argument that we often have. I mean, there's that argument. I'm not a pilot. I don't know. I mean, I don't know how easy it is. I haven't been going to flight school and, saying I don't need to worry about landing. Just tell me how to, fly into something, a la Muhammad al-Atta. I'm not, as I said once famously before, I'm not a jihadist, right, yet. But so the question that I have, I think a lot of arguments are, well, we don't really require almost anything else in our industrial or civilian or commercial infrastructure to be able to withstand a direct aircraft impact. For example, One World Trade Center down, 3 miles from where I'm sitting right now.
Right.
The place where we had, 2 airplanes fly into, right, and collapse and kill thousands of people. I've been in One World Trade Center many, many times. I can tell you that plant that is not compliant with any aircraft impact assessment rule, right, necessary to allow that thing to be able to withstand a 767 crashing into it again. And likely, as we know, I think even if we had a direct hit of a nuclear power plant, there'd be a lot less than 3,000 deaths. There probably would be actually no deaths associated with it. Maybe, some plant workers would die from the crash itself. But the question is, and this is the classical question we have in all nuclear regulation, and I think it's a fair one, is why is the nuclear industry held up to such a different standard in terms of protecting the public than anything else that we have in anything else in our society? I think that's a fair question to ask. I'm not saying nothing in the nuclear regulatory apparatus needs to change. That is not my argument. But my argument is that if a Chinese regulator can build first of a kind reactors in 5.5 years and do it, 42 times or 40 times over, And they obviously have a regulator that works to do, at least achieve that build speed. And we try to build this plant there with an experienced workforce, right? Without there's no atomic safety and licensing board hearings at in China, right? That at least none that you would want to disagree with publicly, right? If they had such a strength problem here, I'm not trying to say that nothing needs to change at the NRC. Hell, I was at the NRC a couple of weeks ago advocating for specific changes that need to happen there. But that is not my argument. My argument is that let's focus on the real issues, including advocacy. And one of the things that is funny, I'll just say, and maybe is this too long of an
No,
answer?
no, I love it.
can
I love
go
it.
on to what
And the people will, they'll rebel if I cut
the
you
people
off.
will. Yeah, well, or there'll be burning effigies of me, no doubt. So one of the arguments that you often hear is, well, we can only put pressure on the NRC. We can't put pressure on the industry. And I just as someone who's done a lot of advocacy in my life, I'm like, damn, most advocacy is focused on corporations, right? And in a way that can work really constructively with the corporations. We can talk about that if we're interested in other examples of advocacy. But I really do think that, one, we need to understand, as you started with this process, that I think obviously there's a huge anti-nuclear movement in this country, and I'm not one to say there isn't. There's a huge anti-nuclear politics in this country as well. But we have made, thanks to the nuclear advocates, including some of the people who maybe I disagree with some of those. I don't mean to in any way diminish their kind of heroic, and not kind of, actually heroic work in making this fight happen. That is a challenge and will be a challenge. I'm not so sure at this point it's the rate limiting challenge that we have to new nuclear builds. As we said, we have a lot of licensed sites. Remember, in the noughties, we licensed something like 15 gigawatts of new nuclear capacity. Actually, we licensed 17 gigawatts of new nuclear capacity in the United States in just 2008 till 2016, right? Of that, we built 2. We started building 4, we built 2. And what I'm trying to say is that really the regulator's fault? That's my question that I asked for you. Is the regulator the challenge here? Now, the regulator does need to improve. The NRC itself admits it. There's stuff that in the CROP, what we call the Construction Reactor Oversight Program, CROP or CROP, right, needs to change. But I am hard to see. I'm struggling here to see how that is the rate limiting factor. And to give you an example of something that I don't know if you want to go to another example of us blaming the NRC for everything.
Yeah, give it.
I can.
Yeah, do it.
So, one of the things that sort of shocked me recently is there was a claim made by the Breakthrough Institute that the reason why NuScale went from 50 megawatts to 77 megawatts electrical in their NuScale power module was because of a change that was mandated by the NRC in the containment peak pressure in the safety evaluation report. And, I was like, I know what that change was. It was actually a relatively minor change. It changed less than 5% the containment peak pressure, and it was to adjust an accident sequence. So I literally reached out to engineers at NuScale. I said, hey, guys, is this actually what happened? And everyone was like, no, this has no relationship to the truth whatsoever. We don't know where they're coming from. And in some cases, they literally reached out to BTI and told BTI, hey, guys, this is not what happened. And yet we still have this persistent myth that the challenge with the NuScale design is that the NRC made some minor tweaks during the design of that plant, rather than maybe that the civil works of that plant, for a plant that is literally 50% of the power output of an AP1000, is more than twice as large as an AP1000, right? And rather, we're focusing on the NuScale power module design, which is less than 10% of the overall cost of the plant. I'm just trying to say, do we want to hippie punch and shit on the NRC? If we want to do that, then we're doing a great job. Do we want to actually get to a place where we're building new nuclear power plants? I think that is what I'm interested in, not in having some deregulatory revolution, right? In pretending that our only challenge right now is regulatory.
And I do think this is a track worth following just a tiny bit more. I feel like a lot of the critique of the NRC comes from the advanced nuclear community, or those representing the advanced nuclear vendors. Do you think that and I've heard one of the reasons Canada is a more attractive regulator in order to pursue that, pursue potentially advanced designs or so-called Gen 4 designs, is because we're less prescriptive. Is that a shortcoming of the NRC? Just really briefly.
So I don't want to, start and talking about new reg 0800 versus new reg 1537, but here's my question. I think that the NRC recognizes there is a lot of prescriptive regulations in Part 50 in particular, right? And also other parts, of an operations on radio. My question for this is, at what country right now in the West, what regulator has issued a construction permit to begin construction on a non-light water reactor today? To my knowledge, the NRC has. I don't think CNSC has issued, right? Kairos for the Hermes test reactor, which is not a power reactor, and therefore it was able to use a different standard review plan, a different set of regulations, right? Was able in less than 24 months, right, to get a issued construction permit to begin building about as non-light water reactor as a non-light water reactor you can imagine. This is a graphite moderated, FLIBE-cooled, triso-fueled reactor, right? And we got through the NRC safety evaluation report process in 18 months. Fast, and it's not like Kairos was just waiting around. Like if it wasn't for the NRC, they would have been done. The Kairos still hasn't started construction on that, right? We have a construction permit. It actually was done in 18 months. Had there not been a mandatory hearing process that took 6 months extra, right? This is required by federal law that no one, including the NRC, supports being there, right? It would have been done in 18 months. And everyone has said the NRC can't do non-light water reactors. Well, I say, hey, they were able to do it in a very, very fast manner, right? Faster in many ways than the actual company was able to begin building. I am not convinced that now, do I think Part 53 is a train wreck? Absolutely. I don't necessarily think the issue that we have for these first-of-a-kind non-LWRs is going to be getting it through the NRC through Part 50, right? There are challenges there, absolutely. But if you talk to the NRC staff or if you talk to advanced reactor vendors, ones that are at least competent, they will argue that they have the ability to go through Part 50 right now and make the exceptions that need to be made using there's also obviously nuclear industry developed standard review plans like NEI 2107 and 1804, right, that allow us to basically use an alternative from the light water reactor review plan. I just am not convinced that I'm not convinced that this is the main barrier. I will give you absolutely the NRC is the current regulatory apparatus is designed to regulate light water reactor plants. Here's my question to you. Should we begin reforming the entire NRC regulatory infrastructure as Part 53 entails to cater to that before we built even one non-light water reactor? Or should we maybe build a couple, see where the regulatory process goes, get that real world experience both with the regulator and with the actual build, and then build our Part 53, Part 56, whatever you want to call it, to actually have a more non-LWR focused, reform. Now,
I mean, James, I would argue that baby steps, and I think you should probably start with your first non-light water reactor being one of these super advanced heavy water reactors we have up here in Canada. But
well, that might be actually might be a challenge in the NRC because the positive void. Oh, yeah. So let me go back, and I feel
let's get back to Vogtle. Yeah, let's get back to Vogtle because we promised the people.
Wait. I want to say one more thing on that. There is a lot of things that need to change at the NRC, right, to get us ready for non-LWRs. I am not trying to say that. I'm pushing the NRC among many other people to change a lot of this shit. This is not my argument, and I'm sorry if I'm saying everything is perfect. No, everything is not perfect at the NRC. It does need to evolve. It does need to change. It does need to adapt. We do need to see a different culture there. What I'm trying to say is that to pretend that is our central challenge is not helpful to us, and we need to actually start figuring out how are we going to deal with more design maturity, right? Uh, and so on.
Okay. I feel terrible because I feel like you probably had a really cohesive narrative. You could have like given a hour-long lecture and, hit on a bunch of points, and I can hear some of my audience members going, Kiefer, stop interrupting the man. I do prefer something conversational. I do think it was very useful to drift a little bit into this territory because
Oh no, I
as you're
loved it.
saying, I'm totally up for a part 4 because I feel like we didn't fully, digest and
Get through
follow
Vogtle.
follow that trajectory that you were mentioning. I think that's probably best. And I like the idea of a 4-parter. It'll give our audience,
Really?
it'll give our audience a little more chance
All
to
right.
digest and give us feedback. Um, is there anything else you wanted to sort of close up with?
Well, no, not in the remaining 8 minutes. I want to say, first of all, I'm a Jewish kid from Long Island, right? If you don't cut me off, I won't stop. So you gotta cut me off at certain points, right? Like, there's many things I am. Loquacious is one of them. But I just want to say, I guess I'm trying. I want us all to level set here and end on the tragedy of Vogtle 4. And that is, we're going to finish Vogtle 4. Vogtle 4 is going to work. It's going to be great. Vogtle 3 is already doing fantastically in terms of operating performance. And it's just very heartening to see. We got to figure out what are the next steps to building new nuclear. And I think we've focused a little bit too on the NRC, the linear no threshold hypothesis, ALARA, right? And not enough on what are the commercial challenges that we're seeing, what actually happened, how do we talk about Vogtle in summer? One of the biggest problems I think that I started this many decades ago when we started the first episode of this podcast, right, was the we don't talk about what happened at Vogtle in the summer. And we got to admit that for a lot of, how do I say this, right? This is not the first time that we've had to abandon a nuclear project mid-construction and let it for a rusty heap. That is part of as great as we are providing 19 point something percent of the electric power of the United States. We also have a long history of destroying the careers of utility executives who order our products. We have a long history of kind of screwing the ratepayer a little bit in the initial construction of this, right? Screwing public service commissions and people who do this. And a lot of that, especially in the 80s and 70s, was anti-nuclear opposition, fair and square. Shoreham in Long Island, 100% anti-nuclear opposition. Obviously things could have gotten better in that build, but you can't really blame that on the industry. But a lot of these cost overruns that we've seen historically, we got to figure out how we are going to be able to credibly say to people how we are going to deliver your product on time and on budget. And this is why, and this is what we've learned about it, and that we're not afraid to talk about what happened in the past. No, we're proud to talk about it because we're proud to explain to you all of the steps that we have proactively taken so that that won't happen again. Once again, I am not, this is not me sounding anti-nuclear. It's me saying, if we got to wake up, get out of our bubbles and figure out what the actual issues that we have collectively in getting new nuclear power built in this country. And that's cost, that's timing, that is anti-nuclear opposition, that is reforms of the NRC, but it's all of these things. It's not just the NRC and the antis.
Okay. Just as a teaser and preview for what's next, and that may change again based upon my wonderful listeners' feedback on Twitter, on LinkedIn, wherever you want to get in touch. What would you say is what do we have left to cover in
So
this
we
episode
have to
4?
skip. We haven't actually. I mean, I don't know if you want to go into grueling detail, and we'll talk afterwards. I kind of slept. I kind of skipped over, like, we these massive litigations, the bankruptcy of Westinghouse, the switching of from Fluor to Southern, from Westinghouse to Fluor to Southern to Bechtel, right? The Bechtel report, what happened in South Carolina in particular. There's a huge stories in each one of these things, and I kind of hand waved across it, only because it's really complicated what happened there. And the challenges that we faced were really, really huge. And we should probably dive deep into that. The issue is that that's pretty painful stuff. I don't necessarily. It's a lot of there's going to be a lot of spoonfuls of sugar that are going to need to help make that medicine go down. And like I guess my question is do we want to have that sort of? I mean, how much do I want to be hated? Is going to be my
Right.
question here. But that's the question I have. So once again, this is not a great part of our collective history, and I think the argument is really there, especially in many regions in the United States, as we start focusing both decarbonization, energy independence, and resource insecurity, real short grid resources as power demand starts, really dramatically growing on the grid. The place is there for new nuclear. The case is really there. And I think until we start addressing all of these issues, including getting some of the toughest topics, some of the hard to bear stuff, we're going to be it's going to be hard to convince people to be able to build this.
Okay, well, listen, I'm not too worried about getting nerdy. We actually moved, hopefully I can sustain this, but to bi-weekly decouple releases. So maybe we can have one like ultra nerd out episode for the nerd core.
And then
And
regular people.
one more, yeah, one more for the regular people. But honestly, I mean, this is a highly intelligent, incredible audience. I'm always impressed by the folks who, meet me at conferences and say, "Hey, I listened to your podcast and I really, appreciated this, that, or the other." It's some pretty high caliber folks, just fluffing the egos of those listening. Again, James, thank you for being here. To the audience, thank you for your support. I could use a little more, so hop on Patreon, and join the community there. We have a variety of different clubs. They're kind of entertaining, different levels of support. And if you want to make a larger donation, you can reach out to me directly, and we'll find you a more efficient way to do that. Again, wow, shameless self promotion. It's happening. But I think this project is important and big, and I don't think it's happening anywhere else. James, thanks for being part of what makes that happen. Really, really appreciate your time, man. I have learned a gobsmacking amount over the course of our podcast together, and in this one in particular. So thank you, sir.
Thank you for having me.